In this video, we're going to be practicing using our properties of exponents in order to simplify exponential expressions, which we spend a lot of time doing when we deal with polynomials or really anything exponential, so exponential functions as well. But let's take a look first of all at what these properties are. And then as we go through these exercises, what I want to do is this. Before we use the property, I want to identify the property that applies in this given situation that we're in. So recapping very quickly the properties of exponents, we have the product and the quotient property, which are the most basic two. And they essentially say that when you multiply or divide things with the same bases, instead of having to write everything out, the quick way to do it is to recognize that you're going to get the same base again, but when you multiply two things with the same bases, you add their exponents. And when you divide two things with the same bases, you'll subtract their exponents. And I do want to make a note here. We say order matters, I think, when you subtract. So if you want to make yourself kind of another little amendment here, I can't fit it in very well, but we say numerator denominator minus denominator denominator, sorry. Numerator exponent minus the denominator exponent is the way you want to do it in. So we say top minus bottom exponent. So other very simple properties, these would be the zero exponent property. Anything to the 0 power is 1 except for 0 to the 0. We have power to a power and quotient to a power, power of a product and power of a quotient. And those come about from our power to a power property. So power to a power says if you were to take a to the m to another power n, we can just go ahead and multiply these two exponents. And then power of a product basically says do the same thing. If you have a product of things being taken to a power, you can go ahead and take everything in that product, every factor in that product to that power. So a to the m, b to the m. And same thing as if you were to take a fraction to a whole power. You would take the whole numerator to the power of m, or the whole denominator to the power of m, so long as b is not equal to 0, because we don't want undefined stuff. So take a look over here on the right. Recall that I said I wanted to identify the property we're going to use in each of these given instances. So we say simplify the following exponential expressions and tell which of the properties of exponents that we use. So we say 2 to the 3rd power, we're taking this to the 4th power. So now traditionally, I just want to show you this. This is why we learn these properties. Traditionally, I would have had to have written this all out. When in doubt, write it out. You know, it's kind of a stupid saying, but it always works. And I'd be doing this. And what I know is this. Now I'm multiplying a bunch of 2's, and I've got 3 here, 3 here, 3 here, 3 here. I could just say I've got 4 3's. So really, when we're using these properties, we say, first of all, which property is this? This is our power to a power. So we say power to a power property here, power to a power. And then also this, we say power to a power says when I take a power to a power, I can just go ahead and multiply these exponents. So this is why we're going to get 2 to the 12th. And as a matter of fact, we should type this into a calculator and get a value for it, but I'm going to leave it as 2 to the 12th for now. Okay. So now taking a look at letter B, we say, what is this here? What do we have? Looks like we have a quotient, so maybe this is our quotient property. And our quotient property says, you know, when you divide two things with the same bases, you can subtract their exponents. Well, I notice that these don't have the same bases, but maybe then it's this power of a quotient property where we say a fraction to a power. I think it is. And so we say, really, this property says that you'll take everything in the numerator, which we represent with this letter A here, and take it to this power. Everything in the denominator we represent with the letter B, take it to this power, okay? So we say our numerator this time, we say is 3. We're going to take it to the 2nd power. We're going to take everything in the denominator, which is 4, to the 2nd power. So in this case, we get 9/16. So the property says we did this. We say power of a quotient is what we were dealing with here. We split up the exponent and then evaluated. In this case, now this is really important, there's a difference between -5 to the -6 and -5 in parentheses to the -6. And the reason why is because here the base is only the 5, whereas here the base is the negative and the 5. So when I put these negatives in parentheses, I mean that these exponents actually apply to them, okay? So I notice here that I've got -5 to the -6 power times -5 to the 4th power. And I want to point out that a few properties actually apply here. Starting with this one, we are multiplying two things with the same basis. So this is our fundamental product property. It says, hey, when you multiply two things with the same basis, you feel free to add those exponents. So in this case, we say the base stays the same, and I would get -6 plus +4 is -2. So now I'm going to come back to this expression and point out that in the beginning, we could have recognized that this had a negative exponent, which one thing we could often do is take that negative exponent. We say a to the negative m is equal to 1 over a to the positive m. We know that if you were to take this base, it has a fraction bar underneath, and move this down to the basement, you would actually get a positive exponent then. Base stays the same, but the exponent switches its sign. So if we get this here, we end up with 1/25. My question is, if we had done that in the beginning, would we have gotten the same thing that we did here when we use our product property? So we use our product property and negative exponent property here. I can't squeeze that in here with my handwriting. But had we done this to begin with, look at what we would have achieved. We said, well, I've got these two things on top, and this is to the negative 6. So if I rearrange things here, I've got negative 5 to the positive 4. That stayed in the numerator, but we say negative 5 now to the positive 6 goes down to the denominator. So now looking at this, and actually this is a negative 5 squared. I do have to have a conversation about that. But we say this here, now I'm dividing two things with the same basis. And when you divide two things with the same basis, hey, our quotient property here says subtract their exponents. So I get, now important, order matters here. We get 4 minus 6, which this becomes, if I keep going here, negative 5 to the negative 2. So again, we have to get negative 5 to the negative 2 here. We have to get the same answer, which is the same thing as 1 over negative 5 to the positive 2. And since I'm squaring all of this, now this is the conversation I needed to have. You're squaring the negative and the 5, so this becomes positive 1/25. Okay. So there are a few using those properties here. Let's go ahead and take a look at some more complex ones. They tend to throw people here. Now I'm looking at letter A. Now letter A reminds me a lot of letter B up here in that we have a fraction to a power. So our quotient property says anytime I have a fraction to a power, we'll take everything in the top to that power, everything in the bottom to that power. So the first thing I'm interested in doing is this. Let's take everything on the top, which is just r, and we'll square it. And then we'll take everything on the bottom, which is s to the negative 5 power. We'll square it. So now looking at this, we say, now let's just simplify the top, and then we'll simplify the bottom. Usually when you work with a quotient, you want to simplify the numerator and denominator separately. So the top here, I have r to the first to the second. Technically, this is my power to a power property that says I should go r to the 1 times 2 and multiply my exponents, but I just get r squared. We can easily recognize that. We say 5 now. 5, and I don't think that this was a 5 here. This is an s to the negative. Let me rewrite this. See, I already forgot that this was s to the negative 5 because of the way I wrote it. So s to the negative 5 to the 2. Again, we're going to take a power to a power. We're going to multiply the exponents. So negative 5 times 2 is negative 10. And we end up with this expression here. So now we need to simplify this further. I notice that I have a negative exponent. We don't want negative exponents a lot of the time. So what we'll do is this. We'll go ahead and stick it back upstairs, at which by it, I mean the s. Its exponent becomes positive again. We could just write a 1 underneath, or we could just write this expression right here. They mean the same thing. So this would be our simplified form of this expression. Okay, let's go ahead and take a look at letter B. Now, letter B, interesting. Lots of b's on letter B. It says 7b to the negative 3rd power. All of that to the 2nd power, then b to the 5th times b. I say that we start with this expression right here being squared. Okay, I think that we could simplify this, and what I recognize is I'm taking 7 times b to the negative 3rd, and all of that's being raised to the 2nd. So in terms of my power property over here, we're saying power of a product. And what we mean is this: if you multiply a bunch of stuff and then take that to a power, we can actually, it kind of looks like distribution of the power up top here. We could say, well, then what I have to do is I have to take 7 to the 2nd power, and I have to take b to the negative 3rd to the 2nd power. So we're going to write this out the long way, but I'm going to say 7 to the 2nd power, b to the negative 3rd to the 2nd power, and then we have b to the 5th times, and I'm going to write b to the 1st actually. So now we have all of this, and I say, well, what else could we do? Well, we say now 7 to the 2nd, that's 7 to the 2nd. B to the negative 3rd to the 2nd, this is our power to a power property. We say this is b to the negative 6 because I have to multiply these. And then over here, b to the 5th times b to the 1st. Technically, we could call this b to the 6th power because I can go ahead and add these. We're multiplying things with the same basis. So last but not least, I say, well, why don't we use our power property here? It's pretty basic. B times b, we can add their exponents. We say 7 squared times b to the negative 6 plus positive 6. Now, negative 6 plus positive 6, of course, is 0. But the 0 power property says anything to the 0 is 1. So this is really 7 to the 2nd, and we end up with just 49 for this original expression. Okay, so that would be our simplified form. And then last but not least, we say letter C over here. Let's take this apart in pieces. Now, remember I said when you're dealing with a quotient, you want to simplify the top and bottom first. So we're going to start up here. I noticed that I have not just a power to a power, but a product being taken to a power. So now I could rewrite this as, well, I have x in my product being taken to the 2nd times y squared, that's being taken to the 2nd. And then in the basement, I still have x to the 3rd, y to the negative 1. So simplifying the top even further, we end up with just x squared on the left here, and y to the 2nd is y to the 2 times 2, which is y to the 4th. And then we say in the basement, we get x to the 3rd, and then we say y to the negative 1. So now we have a few moves at this point. One that I think is pretty standard fare, and I want everybody to be doing, is this. We could do quotient property here, okay? And we have to do it with the things that have the same basis, okay? That is, if I said x to the second over x to the third, that would be x to the 2 minus 3 power. Okay, and if I said y to the fourth over y to the negative 1, I actually get y to the 4 minus a negative 1, which all of this here gives me 2 minus 3. I get x to the negative 1, and oops, this is multiplying. And I get y to the 4 minus a negative 1 is y plus, 4 plus a positive 1, which is y to the fifth. So I get this here. Noticing that I would have to take this x and move it downstairs because I want to make its exponent positive again. We could have arrived at the same result just from this statement over here. We could have said, hey, look, I noticed that 2 of these x's are going to cancel out with 2 of these in the basement and leave 1 behind. And then furthermore, if I move this y up here, it would have become y to the positive 1. And taking y to the fourth times y to the positive 1 is y to the fifth. So really what we look at is we have just 5 y's in the numerator, and we had just a single x left in the basement. Okay, so either way you want to arrive there, you can do this. Okay, but we have to be using these properties of exponents here. Cheers.